Geometry, section 9.1 notes, sine, cosine, and tangent. Let's first discuss what a reference angle is. And in this context, the reference angle we're going to use, it's got to be an acute angle. An acute angle is between 0 and 90 degrees. So when we're using our sine, cosine, and tangent, this is for right triangle trigonometry, which means we will always have a right angle. And the reference angle that you choose, it has to be one of the acute angles. Let's say for this first picture, we're going to use reference angle X. I'm going to circle it. It's the reference angle. Now, relative to that reference angle, we have two legs. We have a hypotenuse. One of these legs is the adjacent leg, and one's the opposite leg. R is always the hypotenuse because it's always opposite 90. The leg that touches the angle is called the adjacent leg. I'll just abbreviate it, adjacent, ADJ. And the leg that doesn't touch the angle is the opposite leg. This is all relative to which angle you choose. We choose angle X as our acute angle, adjacent leg, opposite leg, hypotenuse. Let's take that same picture, but instead let's use reference angle Y. Now the hypotenuse can't change. It is opposite the 90-degree angle. X is now the adjacent leg. It's the leg that touches angle Y. Y is now the opposite leg because it is the leg that does not touch the angle that we're using. Bear with me, you don't know what all this is for, but in general, we need to identify in each picture one of our acute angles, and then from there identify our adjacent, opposite, and opposite leg and hypotenuse. Identify a reference angle, and then identify our adjacent leg, opposite leg, and hypotenuse. Let's check out this first picture. I'm going to come at you sideways here, not tell you what the point of this is, see if we can come to some conclusions. We've recently studied special right triangles. Let's say that our reference angle for this is this 30 degrees. Measure of angle M. Now we know that in a 30, 60, 90, whatever the short leg is, opposite 30, the long leg is that times the square root of 3, and the hypotenuse is twice the size of the short leg. So twice 3 is 6. If we were to answer these questions, what's the length of the opposite leg over the hypotenuse? Relative to M, the opposite leg is 3. The hypotenuse, always opposite 90, is 6. This reduces to 1/2. Interesting? Not yet, but it will get it. Adjacent leg, relative to angle M, the adjacent leg is 3 square roots of 3. Hypotenuse, opposite 90, is 6. This reduces to square root of 3 over 2. Interesting? Not yet. Opposite leg over adjacent leg. Opposite leg is 3. Adjacent leg is 3 square roots of 3. If we simplify this, divide top and bottom by the square root of 3. If we then rationalize the denominator by multiplying the top and bottom by the square root of 3, which is equivalent to multiplying by 1, we're going to get square root of 3 over 3. Is that interesting? No, but it will get interesting. Check out this next picture using 30 degrees as a reference angle once again. This time the short leg is 5. The last time it was 3. If the short leg is 5, the hypotenuse is always twice that, which is 10. The long leg is the short leg times the square root of 3, so that's 5 square roots of 3. See what happens when we answer these questions. Opposite leg, 5, hypotenuse, 10. That's 5 over 10. Guess what that reduces to? 1/2. Interesting? Maybe. This next one, adjacent leg, 5 square roots of 3 over the hypotenuse is 10. That reduces to square root of 3 over 2. Interesting? Perhaps. Opposite leg over adjacent leg, that would be 5 over 5 square roots of 3, which is 1 over the square root of 3, which is square root of 3 over 3. Interesting? Maybe so. Here's what I'm suggesting. That if you have a 30, 60, 90, and you take the opposite leg and put it over the hypotenuse, it will always reduce to a half. It happened 2 times. Doesn't mean it's going to happen every time. If you take in a 30, 60, 90, and you take the adjacent leg over the hypotenuse, it will always reduce to square root of 3 over 2. In a 30, 60, 90, relative to the 30, if you take the opposite leg over the adjacent leg, it will always be square root of 3 over 3. Let's check out this next picture. Using the reference angle of 30, and the short leg being 8, the hypotenuse would have to be 2 times 8, which is 16. The long leg would be 8 times the square root of 3, which is 8 square roots of 3. Opposite leg over hypotenuse, that's 8 over 16, which reduces to a half. 30 degrees, the adjacent leg is 8 square roots of 3, hypotenuse is 16, that reduces to square root of 3 over 2. Opposite leg over adjacent leg, that's 8 over the square root of 3, which is going to reduce to square root of 3 over 3. This is true every time. Now, with that being said, since this is true every time, what we want to do is develop a special name for this, opposite leg over hypotenuse. A special name for adjacent leg over hypotenuse. A special name for the opposite leg over the adjacent leg. The special name for opposite leg over hypotenuse is sine. This is sine, and you have to identify which angle you're using. In each case, in this last case, we use measure of angle t. Sine of the measure of angle t will always equal the opposite leg over the hypotenuse. I wrote down a and I said t. Silly boy. Adjacent leg over hypotenuse is cosine of the measure of angle t. Opposite leg over adjacent leg is tangent of the measure of angle t. Why do I want to write an a so badly? I kind of ran out of space there, so let me make sure this is clear. SIN is pronounced sine in math. It's a shorthand for SINE. Cosine we abbreviate COS. It's still pronounced cosine. Tangent is pronounced tangent. We abbreviate it TAN. Doesn't matter how we abbreviate it, we pronounce the full word. Let's see if we can put this into practice. See if we get the point. And if you don't, I make it, I think, real clear on the back. Write a trigonometric function, which we can abbreviate this trig function, that corresponds to each pair of numbers in the given angle. So all of these deal with angle x. I'm just going to circle angle x. We're supposed to use the 3 and the 5. Relative to angle x, 3 is the opposite leg. 5 is the hypotenuse. Which trig function uses the opposite leg and hypotenuse? So that's sine. So the equation we could write for this is sine of the measure of angle x equals the opposite leg over the hypotenuse. Number 2, same angle, we're using 3 and 4, which are both the legs. Which trig function uses both legs, opposite leg and adjacent leg? Well, that's tangent. Tangent of the measure of angle x is going to equal 3 over 4. Here's what we know, going back to this. If I said sine of measure of angle m is a half, we know that the measure of angle a half has to be 30. Because it's every time you have 30 degrees, opposite leg over hypotenuse is 1 over 2. If I said cosine of some angle, square root of 3 over 2, you know the answer is 30 degrees every time, because the adjacent leg over hypotenuse is always going to be 30 degrees if it's square root of 3 over 2. Tangent of some angle, which gives you square root of 3 over 3, which is the opposite leg over the adjacent leg, that angle has to always be 30 as well. So these trig functions are ratios of sides of triangles, and your calculator has all these memorized for you. All right, number 3. Supposed to use 4, 5, and angle x. 4 is the adjacent leg, 5 is the hypotenuse. So that is cosine of the measure of angle x equals the adjacent leg over the hypotenuse. Question 4, 5, and 6, we're using a different angle. We're using angle y. Relative to angle y, 3 is the adjacent leg, 5 is the hypotenuse. So this is cosine of the measure of angle y equals 3 over 5. The next one is still angle y, and we're using the opposite leg and adjacent leg, 3 and 4. So that's tangent of the measure of angle y, opposite legs on top, adjacent legs on the bottom. Number 6, we're using the 4 and the 5, which is the opposite leg and hypotenuse. So that's sine of the measure of angle y. That equals 4/5. Cool. Write an equation using the indicated trig ratio. Number 7, sine of the measure of angle x. Sine is the opposite leg over hypotenuse. So that means this equals 16 over 34. Done. This could be reduced. Don't waste your time. Cosine of the measure of angle x. Angle x, cosine is the adjacent leg over hypotenuse. So this equals 30 over 34. 9, tangent of angle x is the opposite leg over adjacent leg. So that would be 16 over 30. Number 10, we're using angle y. Measure of angle y, opposite over adjacent. So that's 30 over 34. Cosine of angle y is the adjacent over hypotenuse. That's 16 over 34. And tangent of the measure of angle y is the opposite leg over adjacent leg. That's 30 over 16. Now you might notice some things happening with sine and cosine. In the same triangle, sine of one of the angles is going to equal the same thing as cosine of the other acute angle, the complement, if you will. Here, cosine of an angle is 4/5. Sine of the complementary angle is also 4/5. That is not a coincidence. Sine of x is 16/34. Cosine of the complement angle is also 16 over 34. Sine of an angle is 30 over 34. Cosine of the complementary angle is 30 over 34. Not a coincidence. So let's get down to brass tacks. Here is the nuts and bolts of what's happening. Those nuts and bolts are happening right here. And you have a quiz over this part right here tomorrow. On your quiz, I believe this is drawn for you. This is written for you, this is written for you, and this is written for you. You have to write out this, 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 and this. I believe everything in green you have to write out, and the rest of it's written for you. So let's check out what this says. This is just saying what we just said on the front of the notes, but it's just written more formally. Trig functions in a right triangle. For an acute reference angle y in right triangle XYR, The trig functions are as follows. Sine of the measure of angle y is the opposite leg over hypotenuse. And in this picture, the opposite leg is y, the hypotenuse is r. Cosine of the measure of angle y. It's the adjacent leg over the hypotenuse, which is x over r. Tangent of measure of angle y is the opposite leg over the adjacent leg, so that's y over x. Sin is sine, cos is cosine, tan is tangent. This right here is an acronym. So, sine, opposite leg, hypotenuse. Ka, cosine, adjacent leg, hypotenuse. Tola, tangent, opposite leg, adjacent leg. It's an acronym to help you remember how these things go together. Once again, so, S-O-H. Ka, C-A-H. Toa, T-O-A. This next part is perhaps the most confusing. Mathematically, we have some things attached to each other here, and we have to know how they're attached so we can be able to unattach them. For example, if I said 2 plus 8, how are the 2 and the 8 attached? They're attached by a plus sign. How do you unattach them? Subtract. If things are attached by multiplication, you unattach them with division. If they're attached by squaring, you unattach them by square rooting. So let's discuss. How do you think the r is attached to the sine? How do you think they're attached? Most people would say, well, I think they're attached by multiplication. You'd be right. How do you unattach multiplication? You unattach by division. Now it's this next part that's confusing for a lot of folks. How is sine attached to the angle A? A is an angle. It's attached by the trig function. How do you unattach it? By the trig inverse. I'm going to write down some more about that down here. So for example, if you have an operation, every operation has an inverse operation. No, not every. Most have an inverse operation. Stuff we're doing all has inverse operations. So if I give you plus, inverse is minus. If I say minus, the inverse is plus. I say multiplication, you would say division. I say division, you'd say multiplication. What we are talking about is these trig functions. If I say something is attached by sine, to unattach it, you do what's called sine inverse. It looks like the negative one is an exponent. That's how it's written. It is superscript, but it's not an exponent. Cosine's inverse is called cosine inverse. Tangent's inverse is simply called tangent inverse. So they're named well, even though it can be confusing. So we'll get into more before we're done with this, why this is important, but it's very important. If it's on the left side of a trig function, it's attached by multiplication. If it's on the right side, it's attached by the trig function. Here's some Greek letters we're going to end up using quite a bit. We usually use Greek letters for angles, but not always. This is alpha. Handwriting-wise, it looks like a Jesus fish. This next one is beta. Handwriting-wise, it's like a capital, somewhat cursive, sloppy B. The next one is gamma. It's like a Jesus fish jumping into the water. The next one is theta. Handwriting-wise, it looks kind of like a Pokemon ball. What just happened? Sorry about that. I don't know, things got a little crazy there for me. All the way back. Sorry. I don't know, I hit something and I went all the way back to the wrong page. Theta, kind of like that Pokemon ball. Let's look at a few real examples. Find the missing value. Round measures of segments to the nearest tenth and angles to the nearest degree. There are two different ways to solve this problem. Two different equations we could write. Let's focus on the acute angle we're given, and let's use that one. Now, the other way to do it, which I won't do, is you could use this acute angle, which we should be able to figure out because these added together have to be 90. Using this angle, identify what is this side and what is this side. This is the opposite leg. This is the adjacent leg. Which trig function uses the opposite leg and adjacent leg? Well, that's tangent. Tangent of 40 degrees is the opposite leg, y, over the adjacent leg of 7. We have just written an equation using a trig ratio. To get y by itself, you have to identify how are the y and the 7 attached. They're attached by division. To unattach them, we will multiply both sides of the equation by 7. If you multiply a trig function by something, write it on the left. On the left, we then have 7 times tangent of 40 degrees, and on the right, the 7's cancel, and we have y. This is the exact answer. If you want a rounded answer, you need to put this into your calculator, and we do want a rounded answer. Notice here on my calculator at the bottom left, it says degrees, radians, degrees, radians. You want your calculator to be in degrees. To get to that, you hit the mode button, and then you go down where it says angle, and I believe it says degrees or radians. Make sure degree is selected, hit enter, and then hit second quit to go to the home screen. So I'm going to type in 7 tangent 40. Recognize my 7 as a 2 because my handwriting is so perfect. 7 tangent of 40. The direction said sides, the nearest tenth. That's 5.9. What would have happened if I had my calculator in the wrong mode? If I had it in radian mode, it would be negative 7.8, which is nowhere close to what we're talking about. So we got to make sure that we are in the right mode. That's the end of that problem. This is the rounded answer. This is the exact answer. Check out 14. Identify the angle you're given, the acute angle. I'm going to circle it. Then identify what sides that we have. We have the opposite leg, and we have the hypotenuse. What trig function uses the opposite leg and hypotenuse? Well, that's sine. Sine of our acute angle is the opposite leg over the hypotenuse. Just should mention, trig functions always followed by an angle. And this is always equal to some ratio. Always. Trig function followed by an angle always equals a ratio. Now I'm trying to get r by itself, and I can't do that directly. I'm going to have to multiply both sides of the equation by r to get r off of the bottom of this fraction. That's going to give me r times sine of 48 degrees equals 5. To get r by itself, I have to unattach it from sine of 48. It's attached by multiplication. To unattach it, I have to divide both sides by sine of 48. On the left, the sine of 48 degrees cancel. On the right, we're going to end up with this fraction. This is the exact answer. To get a rounded answer, I'm going to put this into my calculator. Five divided by sine of 48. That gives me 6.7. This is a side. It's the hypotenuse. The direction said sides, 1 decimal place. Let's check out 15. Now 15, we don't know the angle, we're trying to find it. We still identify the angle that we're trying to find or the angle that we have. Relative to that, 5 is the adjacent leg, 17 is the hypotenuse. Which trig function uses the adjacent leg and the hypotenuse? Well, that's cosine. So we write down our equation. Cosine of our acute angle, alpha, equals the adjacent leg over the hypotenuse. Now here's where it gets a little interesting. We're trying to get alpha by itself. Currently, alpha is the angle. How is the angle attached to the trig function? According to this, the angle is attached to the trig function by the trig function. Trig function is sticky on the right side. It attaches itself to the angle. How do you unattach it? You unattach it by using the inverse trig function. So we're going to apply cosine inverse to both sides of the equation. When you write an inverse trig function, you must write it on the left. Left side of our equation, cosine inverse and cosine cancels, which gives us alpha. On the right side, we get cosine inverse of 5 over 17. This is our exact answer. To find a rounded answer, we're going to put into our calculator cosine inverse of 5 over 17. And to the nearest degree, because that's what the direction said, this is 73.89 is 74 degrees. I'm sorry, 72.89 rounds to 73 degrees. So 2 wrongs made a right in that situation. On your calculator, you're going to have to write down, you're going to have to type in second and then cosine. Because if you look above the cosine in your calculator, it's yellow up there. So to get to the yellow things, you hit second first. Second cosine and then 5 over 17, you get 73 degrees. If you were in radians on accident, you would get 1.27 degrees. Being in the right mode is going to dramatically affect the answer. All right, 16. We got 2 different things to find. Starting with our acute angle, 10. Relative to that, 8 is the opposite leg. R is the hypotenuse. What's x? X is the adjacent leg. Let's try to make our equations here. We would like to only have one variable in each equation. So relative to the 10, we have opposite leg and hypotenuse. That would be sine. Sine of 10 degrees is the opposite leg over hypotenuse. If we want to make an equation with the x, we could do opposite leg and adjacent leg. That's tangent. Tangent of 10 degrees is 8 over x. Now these need solved, and these can both be solved the same way because in both cases the variable is in the denominator. Let's solve the first one first. What a novel idea. We want to separate the 8 and the r, so I'm going to multiply both sides by r to get the r off the bottom of the fraction. It's going to give me r times sine of 10 degrees equals 8. And I'm going to divide both sides by sine of 10 degrees. If I put that in my calculator, I'm going to get about 46.1. Solving the second equation, if I multiply both sides by x, the left side I get x, tangent of 10 degrees is 8. If I divide both sides by tangent of 10 degrees, and then put it in my calculator, I'm going to get 45.4. Now these answers should be, you can't just look at these answers and tell if they're right, but you can look and see if they're reasonable. Does it seem reasonable that if this is 10 degrees, that 8 would be the smallest side? It has to be the smallest side. 8's clearly smaller than both of these. That makes this angle 80 and this angle 90. Opposite 80 should be pretty similar to opposite 90. These are similar. But opposite 90 should be the biggest one. That's what R is, and it is. So at the very least, if these answers aren't right, they're reasonable. They are right, by the way. All right, that concludes the notes. Please do the homework for 8.1 and pardon me, for 9.1. I super love trig, and hopefully you will grow to love it too.